Start streaming. All right, let's see if this works. Let's see. You are live. The internet can see you. Fantastic. All right, so I haven't done YouTube for a while. No reason. I've been super busy. We went to an awesome techno security conference and hung out with a lot of people that do more data analytics, which was really fun. And we just did masterclass, which was really amazing. We had a whole bunch of people from all over the world here, picked up the whole shop, went to a hotel for 8 days, and that was really fun as well. So we're back. It's course week, regular course week, and I wanted to give you guys this little PSA on iPhone 10 aftermarket LCD screens. This came up recently, and I want to just make sure that everybody is aware of what's going on with these things. Let me just check to see if this is working. Looks like it is. A bunch of people are on chat. Long time no see. Yes. So what we have here is Kyle's phone. So Kyle brought us this a few weeks ago, and this is an iPhone 10, and this iPhone 10 is all tore up here at the screen connector. So this is really bad. So how does a phone get to be like this? This is burn. Look at that. This is completely torn up, all sorts of burn. The connector itself, I already took off. It was completely fried, plastic melted, and all mangled and mashed. Now this case is something that I've heard about a few times out there. So this is not unique. This is a problem that everyone should be aware of. So how did Kyle get into this mess with his iPhone 10? And the answer is that there is a installation problem that you can have when combined with some of these aftermarket LCDs are kind of low quality. You can get into trouble here. The way that you get this much heat on a board is from a short circuit. So at some point in time, there was a short circuit. Now let's try to figure out, let's be detectives and try to figure out how this happened to Kyle's screen. So the normal iPhone 10 doesn't use a LCD. The normal iPhone 10 screen that comes with it is the OLED screen. That's a different style. It doesn't have a backlight. So when you use the less expensive aftermarket LCD screens, you're really changing the design of the phone. You're asking it to do something differently. So how do you think an iPhone 10 LCD with a backlight, how would a screen like that even work? So let's take a look at some of these screens and try to figure it out. Well, there's no backlight circuit in the iPhone 10, so how the heck could you possibly, make one of these screens turn on? So this is one of the aftermarket LCDs. This is Kyle's screen. And then I've got a bunch of these other screens. These are the native OLED screens. So let's try to figure out, if I was trying to make a screen that had a backlight, what would I need? Well, I'd need a backlight circuit. And we know a lot about how backlight circuits work. They all start with main, VCC main. They all have a driver chip, a coil, a diode, and an output. So there's gotta be that element. So I guess if I had a source of main, VCC main, I could make a little circuit that had my own driver and my own diode and coil. I could make a backlight driver circuit as long as I had VCC main. Now let's look over at the iPhone 10 native connector and think, how could I come up with a source of VCC main? So this is the place where you plug in that OLED screen. And what is going on here? This is a normal connector. Now normally we expect on the ends of connector to have ground, and we do. On this side there's ground there, and there's some ground pins throughout. But here's what's weird about this connector. The other side of the connector is not ground. What's this line? This is, can you see down there? PP VDD main. Wow, so there's two main power rail pins here at the connector. I wonder if I could design a screen where I plug it in and connect to main and route that through my own flex to get to a custom little driver chip on the screen. That's how I would do it. That's how you would do it. Let's see if that's how they actually did it. So let's click over. Let's actually look at this screen. So we dissected Kyle's screen a little bit to try to do some post-mortem on this and try to figure out what the heck happened. Because my initial thought was, I bet the screen has a backlight circuit that had a short, just like an iPhone 6 or 6S, but that does not appear to be the case. Let's see what you guys think. Let's click over to the microscope and follow this sort of screen connector. So here we go. All right, this is Kyle's screen, the one that got all tore up. And you can see all of this massive damage. Now, how does that correlate to the actual screen that we're looking at? It would, or the ZXW, if we plugged it in like this, that would make our main side over here, which is the burned up area. So that's sort of consistent with, how did it get to be like this? Somewhere there was a short. So let's follow and see where might this go. And if we just kind of look up the flex, we can read the board that the flex looks like there's this giant area here. And if we scrape into that, we'll probably get to the underlying circuitry. All right, so we've got like a big, whatever that line is. And then on the edge here, sort of all burned up, we can see this torn trace right there, this guy. That's probably where we got into trouble. And if we follow that a little bit more, we can kind of see where it goes. Okay, that's something else. Now let's follow down this flex and see, where do these guys go here in the LCD screen. So I'm going to flip this over, follow, and now I get to what seems like a potential problem. Look at this. As I look at that, that is a crease. Oh, that really jumps out as you as in the you can't do that column. This reminds me of the iPad mini digitizer problems, where in the iPad mini digitizer, you couldn't allow the flex to touch the adhesive, because if you did, it would stick to it, and then when you went to install it, it would flat out bend. And they're not supposed to bend in the iPad mini digitizer. This area, the flex was supposed to make this gentle curve, kind of like a curve around a pencil, something like that, rounded edge, not a crease. Now, when you start talking about aftermarket flexes, these guys are designed by somebody else, and a lot of times the materials that are made to use these flexes aren't the same as in the original. So it makes them sometimes thinner. I mean, this is just a bunch of wires that are spray painted, right? This is spray painted wires, that's all it is. And they're really, really thin. This material of the flex probably isn't really, you know, as pliable and flexible and supportive. It could just be paint, who knows. Now let's look and see, I'm worried about that crease. Let's kind of see what might have been the consequence there. And I'm going to bend this over, and we're going to really study the actual creased part here. So let's look at that, and let's even drill down on that one spot. Let's drill down there. Let's focus that up for you guys. And I want you to really be forensic examiners as we stare here at this crease. So I can see at the crease part, let's kind of bend it a little bit so that we can see the consequence of it. I can see some spots where I actually have, I can see the copper wires coming through. Look at that. Do you see copper? Look right there. See that? Just that bend, that crease is enough to take away the coating. That right there is expired wire. That is maybe electrically active, I don't know, but that's exposed now. That could touch ground. Maybe it is ground, I don't know. But that is probably a really big deal. So let's not decide that that's the cause just yet. Let's continue to follow this flex. So this one here is touch, so we're going to kind of pull that away and follow the LCD one. And then we get to a little area here on the back of the screen, and this had a shield on it that I took off. Now let's see what's going on in here. What do we see? Aha, I see coils. I see a chip. I see a diode. This looks a lot like a traditional backlight circuit, and we could guess that we have a backlight driver chip, and we've got some coils, and we've got a diode. This is probably backlight. So then we could probe around and say, well, is anything in here short to ground? Could a short to ground here at maybe this cap have caused a problem that pulled current through VCC main down into the hole to ground here at the short. So let's use our multimeter to ask the question, do we have a short out here? And initially, this is what I thought was probably going to be the case. So let's find out. All right, multimeter, let's say that we're going to guess that all of this bracket edge is ground. And we can kind of probe around, say that's ground, that's ground. All right, so now let's ask, is the coil on a shorted line? No. So I have a normal diode mode reading of about 500. Same for this other one. How about this cap? One side is ground, one side is not ground, just as expected. If you probe around here, I couldn't find a short to ground. So that kind of exonerates this backlight circuit that I thought was going to be the failure point. Well, it doesn't sound like it. It sounds like this is all spared from a short circuit. It wasn't out here at this chipset area. So we had to have a short. Where was it? Let's guess. Let's guess that we had a short to ground that was created from here at the crease. That exposed metal touched something. Now let's take it one step further and see if we can kind of investigate what do these lines go for? Like, maybe it's all mostly ground, I don't know. So I'm gonna swap this out with we'll do an investigation on one of these other screens. So this one's Kyle's screen, so let's kind of put that to the side. And let's take one of these native screens to try to explore a little bit. So first, let's look. I have 3 native screens. I picked this saltwater one here because it, I think, is going to be really, really believable that this is exactly how the OEM screen came out of the phone, because nobody certainly has messed with this one. So this is sort of a native pulled out screen. And I want to look at right here, and let's just kind of see how does the native screen fold. So let's see if we can get this thing to focus right on that. All right, so we can kind of see that there is a roundedness right here. Look at that. See how my pencil, it kind of fits right around that? I don't think I can make that any more focused, but we can look at it under the microscope. Let's see. Can you see that, buddy? How about right here? Autofocus. Focus, you fuck. That's worse. All right, we'll let it do its own thing. Let's look at this same spot under the microscope. All right, so under the microscope we can see, all right, so this is how it natively goes in the device. There's a really gentle, rounded, whatever you want, however you want to call or describe it, but there's no crease. Kind of fits like this, and it rests inside the device like that without making a crease. Let's see, are they all like that? So let's grab another one that came out of a phone and find that same spot. See that roundedness, no crease. And let's look at this other one. There's that roundedness, no crease. So that is really important to mimic the way these things go in natively. This is exactly the same thing that happened in iPad minis with the aftermarket screens that would sometimes ghost touch or have no touch. Some of that was just electricity along the edge of the digitizer, but some of that was the flex actually getting creased just like this. So let's explore a little bit and say, all right, how is this supposed to fit in? I believe you, I'm not supposed to get a crease, but it's really easy to get a crease, especially on these aftermarket LCDs. So this one is a native LCD, and you can see it's kind of bent, but there's no like paper folded strong crease. Let's look and see what we can learn about what these different areas code for. Or code for, that's kind of like a genetics term that's still with me. Code for, well, let's see, what is this code for? What is this strip of protein code for? All right, let's do a little probing around. Okay, so if I say, tell me what is the little thin trace right here, thin, 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 that goes all the way over here. What is that? So I scraped up a piece of it right here so that I could kind of get a reading, and then I'm just going to probe in continuity mode and say, what does that match here on the connector? All right, so it's ground, 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 or whatever it's beeping to. I can get a pattern, right? And then I can match that to the board view and figure out what does this code for. So I'm getting a beep to the end of the connector, and then also on the 3rd pin, 4th, 5th, 6th, 7 are all beeping. Now let's go look for that pattern on ZXW and see what we can make of that, and see if we can make a match. All right, so if we kind of guessed how do we plug in that connector, where is a spot where we would have the same thing at the end, plus 3rd one in, 4, 5, 6, 7. Aha, that little skinny edge must be ground. All right, so that little skinny edge must be ground. Fantastic. Now let's figure out what the rest of it is. Let's see. So let's go back here, and we're going to do the exact same thing, where I have now scraped on one of the sort of the big fat part that's right next to the skinny edge, which we know is ground. Let's see what the heck is this giant fat piece here. So I scraped it so that I could probe. I'm going to put a probe there, and now I'm going to figure out what the heck is that. Listening for beeps. And I'm getting a beep here at the other connector and a couple of pins near. All right, so what does that mean? The other sort of anchor pad is what? What does the XW have to say about that? Well, the other side, the side that's not ground, is main. So that's main. VDD main. All right, so then that kind of gives us a really strong story so that we can start to figure out what happened here with this. So now we know that in these flexes as designed, the giant, huge chunk of this flex is all main. And this next door neighbor, the skinny little guy, is ground. So let's compare that back to Kyle's. So here, let's grab Kyle's that blew up. And let's look at his. Oh my goodness, look at the part here that's like the worst of the burn damage. It's all in the VCC main area, and we can see that the little skinny ground is it's burned. And so this must have like caught on fire until this little ground piece burnt up and made an open circuit then. And then everything stopped and was just a mess after that. So we almost certainly got into this mess because of, let's flip it over. Here's our little skinny ground. As we follow it and we get to this crease area and we look right there in this crease, there's ground, there's main, and let's flip it on the other side and we can see that exposed little fleck. You know, there's like, look at that. That is exposed metal. Aha! What do you guys think? I think that the reason that Kyle's iPhone 10 connectors all burned up is because he installed this screen. This screen had a flex that is really susceptible to, you know, the paint of it flecking off. It's not as strong or robust because it shouldn't get exposed metal from bending it. That combined with an installation problem. So let's look and see, does this one have that nice rounded edge? You know, not really. It's kind of rounded and then mashed down right like that. That is what you want to avoid. This right there, letting that flex make a fold can kill your iPhone 10, so beware. And when I went back and I talked with Kyle about this case, when I went back and talked with him, I asked him to tell me a little bit more about the history, and he said, I don't do a lot of iPhone 10 screens. I try to avoid them. When some guy came in, we decided to do, and he's like, I've had so much trouble with this because the first time I put in a screen, it went out fine, and then a couple days later he came back with it being dark, so it just didn't work anymore. So Kyle thought that screen was bad, and that was one of these aftermarket LCDs. So I've since kind of asked around and I've talked to people that if you have just a regular OLED screen and you plug that one in and you get a crease, that can just cause it not to work, and you'll just have a dark screen. So what you might think is a defect is actually an installation problem where you have creased the flex. So be careful of that. So when Kyle said, yeah, first we had one that came back, the same phone came back with a dark screen, and so we installed another one, and then it came back like this, all burned up. That probably both cases were a combination of that screen being really susceptible to not having a rounded curve there on your installation. And in this case, it was so severe, it pressed down, it even went out for a few days, and it came back like this because it took a few days for that piece of metal there, the exposed main, to actually touch ground either next to it or in the area. So let's see. So we can say it was done by the dodgy installer. All right. Sure looks like that ground path was very insufficient for the amount of current it needed to handle. Well, that's the other thing, is that you have to really be careful, especially with these home buttons. You know, the YF home button or whatever it is, I haven't had a chance to try yet. But you have to be careful with some of these modifications and workarounds. It's cat and mouse where, yeah, it's nice to be able to have an LCD screen on your iPhone 10 to save money, but it wasn't intended to have a backlight circuit running through that connector. That's a really big design change. And a lot of times we don't, you know, not even Apple, and certainly not, you know, guys in China designing these modifications don't have the time to do all the safety testing and worry about temperature tolerances and things like that. It's sort of like, hey, does it turn on and work? Great, sold. You get it out the door. Let's manufacture it. Let's make a big bunch of them. All right, let's see. This whole problem could have been saved by a tiny piece of Captain tape. It is definitely true. So you could put Captain tape if you were worried about this. But I think with, like in the iPad mini, once you're aware, okay, when I press this screen in, I need to watch it go in, and I need to make sure that it's not touching adhesive and forcing itself to actually fold and crease. So there we go. I once had one shorted on VDD main on digitizer FPC. Yes, so beware. I would consider avoiding the aftermarket LCDs on iPhone 10. It's just too big of a change, and as we can see, it's a really horrible thing to do to a phone if you do get a short on that line. That causes really, really catastrophic damage. So I'm gonna end this stream so that it can turn into a video and it's not so long and people can't ever watch it. And then separately, I'm gonna fix Kyle's connector and see if we can get this working again. But make sure that you don't let this happen to you. Stick with the OLED screens for your iPhone 10 and pay attention to the flex. Make sure that it is rounded when you plug it in, and you should be good to go. I'll catch up on chat later, and let's put this one in the done pile.